So the paper is about, my research work is about the software testing optimization for the large system, and we using the agent-based technique and different optimization algorithms like NSGA-II algorithm here in this research work. So first of all, the testing process is sometimes very hectic and time prolonged process. So if we are doing the testing for the product lines or the large system, so it will take much more time, and because in the large system we have varied set of features. Okay, so here we have different multi-objective algorithms. In this article we use the multi-agent system evolutionary technique on these large system to make the testing process optimized. Okay, so let's move to the slide number 3, where I mention the outline of the today discussion. Yes. So then slide number 4, there is an introduction. What is evolutionary multi-objective agent system is a population level integration to the evolutionary process. Okay, and agents can reproduce or create the agents or can remove the agents. Okay, and in this approach or in this technique, agent-based system interact technique, and the different they communicate with each other. So these agent-based technique provide some optimized solution. Okay, like for example, in our research problem, we are going to optimize the test cases and the and the what you say time sorry cost. So on the other hand, we are going another algorithms. If we go to the slide number 5, here I discuss a little bit slide number 5. Yes, so here we discuss a little bit in state of artwork and discuss about the working methodology of these two algorithms. Okay, so then we say in this EMAS approach, the solutions or the genotypes are allocated to the agents, and they are conscious of variety of options. They have to improve their solutions. Okay, but in the NSGA-II algorithm that was proposed by the DEP. Okay, so it based on three things. It make use of illicit law. It it select the solutions. Okay, and concentrate on the non-dominated solution. Okay, and it make use of developing or preserving the quality mechanism. So then here the slide number 6, we will discuss about the EMAS algorithm. Okay, agent-based algorithm. Basically, we initialize the progress, we produce the population. Okay, and we have some conditions. Then we reproduce, and then we have stop the process or update the process, depend on the conditions, if we get the optimized solution or not, and finally we have end the process. So then we have the method description for our research work on the slide number 7, if you can move. So basically we select the feature models that we considered as the large system, and these are basically, we say these are the software product lines, and we have different set of features with particular or specific constraints. Okay, so we have configurations different. We make different configurations like the example of, if we say we have a product line of mobile, so from one this mobile feature model, we can make different products. Okay, if we configure the different features. Okay, so each a set of feature make one product of a mobile. So similarly, if we configure different features, we have different numbers of products of mobile. So these configurations we make suits, and we select which are valid configuration and which are not valid. Okay, so we make a population set from these individuals. Okay, so basically, as in the beginning, I also said that we are going to optimize the testing process. That means we are going to reduce the number of test cases. So if we go to the slide number 8, where we discuss our experiment setup and results. Okay, so we have the two main objectives in our research article to be optimized. Number one is minimize the number of products. Okay, that is in terms of reducing the test cases, and minimize the testing cost. That is our second objective. So how we organized our results, we have the number of generations for two multiple objective algorithms. Okay, and these number of generations we select 500, and the population size is 200. So sorry, here we have we select a video player system. Okay, with these number of features and configurations. And what is the SAT solver is doing? Uh, it is basically creating the number of pairs. Okay, so then if we go to the next slide number 9, we use or we select a different number of parameters, where we say we have and these are specific term. Sorry, I want to mention here for the evolutionary algorithms. Okay, so we use the crossover operator, we have the mutation operator, crossover operator we select 60%, and mutation operator 30%, and population size we select 200 for our large system, that is the video player. Okay, if we go to the slide number 10, where we have the results. Okay, so the result discussed in this table number 3, and these are all predominance and non-predominance. So we are saying that for the basically here we are comparing the results for the two algorithms. For the agent-based algorithm EMAS, and for the NSGA-II algorithm. And suppose EMS creating 219 solutions, and we have non-predominant solution 43. Okay, so while the predominance is 176, so percentage for the non-predominance 19.7. Okay, and predominance 80.3. So for the NSGA-II, we are for the previous settings like population size and mutation and crossover, we have these solutions: 187 non-Pareto, 27, and Pareto 160, and we get 14.4 percent non Pareto dominance. So in this way, from this table, you can compare the performance of these two algorithms, and we can observe that EMS is more more better as compared to the NSGA-II algorithm in terms of performance and generating the non-Pareto results or solutions. So can you please go to the slide number 11, where we conclude our research work. So the optimization process with different number of objectives seems to be challenging. As we try to optimize one object, then maybe another object can be affected. Okay. So we discussed the practical utilization of NSGA-II and EAMS to resolve the issues of search-based software testing. Okay. And we are comparing here, and this is the novelty of our work. The experiment output described that EMAS algorithm generate more optimized results as compared to the NSGA-II. So for the future work, we are planning to adopt the NSGA-III algorithms with the three objectives to solve the problems of the large system or the product line with the perspective of the testing issues. So this is all about my research work. So thank you very much for the audience, and thank you very much for everyone here.